Welcome back to the video session. Today's topic we'll see logical connectives and the truth table. So in the previous video session we have seen what is a proposition and what is a very good example of a proposition, and then next we have seen the types of proposition and what are all the connectives we have and what is the hierarchy we have in the logical connectives. All that we have seen, and today's class we will see once again. I'll just brush up the connectives because we are in need of construction of the truth table for the various connectives. Let me just give you the brush up of the connectives. That is, we have first one is negation, that is we will denote it to be as not, or otherwise we have this tilde symbol. Next is we have disjunction, that will be denoted as or. Next we have conjunction, it is denoted with and symbol. Next we have conditional connective, and the conditional connective is denoted by if and then. Finally we have biconditional. So biconditional is if and only if. So these are all the very basic connectives which you might have studied in the digital electronics paper. The same connectives we will make use here in the discrete mathematics course also. We have all these 5 connectives, and the hierarchy is given for negation first, conjunction second, third one disjunction, and fourth for conditional as well as for biconditional. So conditional we have if and then. So if and then, it is only a forward thing. If this is true, then this is also so. Biconditional is if and only if, which means that it is true in both the sense, forward as well as backward. So these are all the connectives we have seen in the previous session, and today we will see the construction of the truth table. So even before we enter into the construction of the truth table, suppose in case we have got 2 variables, right? So we have got 2 variables. If 2 variables are given in a statement, then how many number of rows do we have in the truth table? So it is 2 power 2, which means that we will have 4 rows in the truth table, right? Suppose in case if we have n variables, in that if we are supposed to construct a truth table, so then how many rows do we have in that? So it will be 2 power n, so which means that we will have 2 power n rows in the truth table. So this is how we will be keeping in mind that the number of rows will be inserted into the construction of the truth table whenever we have 2 variables, 3 variables and so on. So let us just see how to construct a truth table for the various connectives. Suppose for example, first thing for negation, let us see. For negation, let us see what will be the truth table. Say for example, if I have the variable as p, then not p it will be denoted, or negation p will be denoted as not p. So here I can have the truth value as t, or I can have the truth value as f. That is the only possibility for this variable. And if the statement p has a truth value as t, then the truth value of negate p will be f, and the truth value of negate p, if p is false now, then we will have it to be as t, right? So this will be the construction of the truth table in case if we have a negation as a connective, right? Understood? So everybody must be thorough with this construction of the truth table. And next is we will have, suppose in case how to construct the truth table if we have 2 variables. Say for example, I will just do it in a one full stretch truth table. So we will have suppose in case let's see for conjunction, that is and here. So how to construct the truth table? Suppose in case if I have got 2 variables, say pq, right? So if I have 2 variables now, then how many number of rows do we have in this truth table? So it will be 2 power 2, which is 4 rows we will be having in the truth table. So what are all the various possible assignments of truth values these variables will take? Let us see that. So we'll have TT, we'll have TF, we'll have FT, and we'll have FF. So P and Q. So how do we construct the truth table for the conjunction connective, which means P and Q will have the truth value as T only if both P and Q has a truth value T. Otherwise, it will have the truth value as only F. Understood? So now here see P and Q will have the truth value as T if both P and Q has a truth value as T. Otherwise, we will have the truth value as only F. So this is for conjunction. Next for disjunction we will have. Next for disjunction. So disjunction is R, right? So which is PRQ we will have. Here also in this statement I have got 2 variables. So then how many possible rows we will have in the construction of a truth table? We will have only 2 power 2, which is 4. So this is how we will have. And how do I give the truth value of this P or Q? So P or Q truth value will be F if both P and Q has a truth value as F. So here I do have P or Q will have the truth value as F if both P and Q has a truth value as F. Otherwise, the truth value is only T. The truth value is only T. So this is the truth table for the disjunction connective. And next we will see for conditional and biconditional. Conditional, that is if and then, forward. Here also suppose in case if we have 2 variables, then possible number of rows we will have is 4, TT, TF, FT and FF. So what will be the truth value of if P then Q? If P takes a truth value as T and Q takes a truth value as F, then the resultant truth value of this statement will be F. Otherwise, it will be only T. Understood? I repeat here, if the truth value of P is T and the truth value of Q is F, then the resultant truth value will be F. Otherwise, it is T. So this is how we will be constructing the truth table for the conditional connective. And next we will see for a biconditional connective, that is forward as well as backward. Here we have. Here also again this statement has 2 variables, so therefore we do have 4 rows in the truth table. So now let us see here what will be the truth value of this statement. So if both P and Q have the identical truth values in the sense both P and Q should have either TT or it must have FF. So if both P and Q has the identical truth value, then the resultant will be T. See here I have got the identical truth value, then it is T. Here I have got the identical truth value, I have got it to be as T. So elsewhere it will be only F, right? Understood? So this is how we will be constructing the truth table for the various connectives. I will repeat here truth table for the various connectives again. So negation I will have not here, that is suppose in case if I have a variable as P, then negation of that is negate P or not P we will call it. So if P has a truth value as T, then negate P will have the truth value as F. If P has a truth value as F, then negate P will have the truth value as T. Next for the conjunction connective, and let us see how do we construct the truth table. So here also for 2 variables P and Q, how do we construct the truth table for the connective conjunction? So here P and Q will have the truth value as T only if both P and Q has a truth value as T. If not, we will have only the truth value as F. That is for the conjunction. And next for the disjunction, again here P and Q we have 2 variables. So for those 2 variables, it will have the truth value as F if both P and Q has a truth value as F. Otherwise, it will have the truth value as T. And next for the conditional statement, P conditional Q, that is if P then Q, it is only a forward thing. So this will have the truth value as F if P has a truth value as T and Q has a truth value as F. So elsewhere it will be only T. Next is biconditional, that is if and only if, which means biconditional Q, the truth value will be T if and only if, or if both P and Q have the identical truth values. Identical truth values in the sense I'll have TT here, they are identical, so therefore the truth value is T here. Here also it is identical FF, so therefore I'll have the truth value to be as T. But here if you see, I have got a mixture of T and F, so therefore the net resultant will be F. So for biconditional, the truth value will be T only if the truth values of P and Q are identical. So this is how we will be constructing the truth table for the various basic logical connectives. Right? So keeping all these in our mind, now we are in a position to just write down the symbolic form of any given statement. Right? We know what is a statement, we know what is a proposition, and once if a proposition is given, how to express the proposition using the suitable connective and write it in a symbolic form. Let us see one example here. If P represents Anil is rich, right? If P represents Anil is rich, Q represents Ram is poor, write the following in the symbolic form. So what is that first subdivision? It is either Anil or Ram is rich. How do I represent this in a symbolic form? Either Anil or, so this or that. So which means that either Anil is rich or Ram is rich. Anil is rich, we can denote it to be as P, right? P is denoted as that. Disjunction R. So Ram is rich, Ram is poor is given to be as Q. Ram rich is nothing else but what? Negate of this. So the symbolic form of either Anil or Ram is rich is P or negate Q. And next is Anil is poor and Ram is rich. How do we represent this in a symbolic form? Anil is poor, so Anil is poor is represented what? Here P represents Anil is rich, poor negate of that. So negate P and we have, so conjunction is the suitable connective. See, whatever terms are given here, we will have to suitably find out the connective. Ram is rich, Ram is poor is Q, negate Q, right? So this is how we will write the symbolic form. Next, third one, it is not true that Anil and Ram are both rich, which means that they say that Anil, Ram are both rich is not true. It is a false statement. So how do I represent this? Anil and Ram are both rich. Anil rich, I can denote it to be as P. Fine. Ram rich, Ram poor is Q. Ram rich, it will be negate Q. Right. So both, which means that and what does it mean? It is not true that. So this statement should not be true, which means that negate of P and negate Q, right? So that is the symbolic form of this statement. Next, again you see here another example. What it says is that if either Mr. Srinu takes calculus or Mr. Sami takes graph theory, then Mr. Magesh will take computer programming. So first thing what we will have to do is that once if a statement is given, we will have to identify the keywords, assign the variables to the identified keywords, and then we will have to represent it in a symbolic form. So what are all the keywords we have here? Srinu takes calculus, let it be P, right? Let it be P. Srinu takes calculus. Srinu takes calculus. Next is Sami takes graph theory and Magesh takes computer programming, right? So these are the three keywords which we have identified in the given statement, right? So I have denoted it to be as PQR. So now that we will have to symbolically write down. What is it? If either Mr. Srinu takes calculus or Mr. Sami takes graph theory, if this happens now, then Mr. Mahesh will take computer programming. So how do I represent this? If either Mr. Srinu takes calculus is P, right? Or here we have Mr. Sami takes graph theory. So, which means that I have got here R. Takes graph theory is Q. Fine. So, if this is so now, then is a conditional statement. Mr. Magesh will take computer programming. So, Mr. Magesh will take computer programming is R. So, only thing is that we must be aware of all the basic logical connectives, and we will have to suitably replace those connectives in the given statement. Now, understood? Okay, fine. So, next we will see what is tautology, what is a contradiction, and what is a contingency. So, now what is the difference between all these three, right? So, tautology means whatever expression is given to us, we must be able to get the truth value as T everywhere for the entire statement, right? If we have the truth value as T for the entire expression, then it is said to be a tautology, right? Understood? So, tautology means if we have the truth value to be as T everywhere, then it is said to be a tautology. Next, contradiction. So, what is all about contradiction? This contradiction is the complementary part of the tautology. So, contradiction in the sense that whatever statement is given to you, that entire statement should have the truth value as false everywhere. So, if we have the truth value as false everywhere, then that statement is said to be a contradiction statement. So, how do we write now? The truth value for this, the truth value is F everywhere for the entire expression, So, if we have the entire expression truth value to be as F, then it is contradiction. Then what is all about this contingency? So, contingency, it is a mixture of both T and F. So, whenever we have the truth value to be as T, F, truth value is either T or F in the entire expression, if it is in the mixed form, then we do call that statement to be as a contingency. Now, understood? Tautology is nothing else but whatever expression is given or whatever statement is given, if we have the entire truth value to be as T everywhere, then it is said to be a tautology. Contradiction in the sense, whatever expression is given to us, if you are able to get the truth value as false everywhere, then it is said to be contradiction. Contingency is a mixture of these two, right? So, the entire expression, either it may have the truth value as T or it may have the truth value as F. So, it will be just a combination of both the truth values T and F. It is called as contingency. So, now let us look into the examples. So, construct the truth table for this statement. So, whatever statement is given to us, even before we go for construction of the truth table, we will have to see how many number of variables are there in the statement. So, how many number of variables are here? There are only 2 variables. List down those variables. So, I have got PQ. PQ are 2 variables I have got. And now, whenever I have 2 variables in the statement, how many number of rows I do have in my truth table? It is 2 power n. So, 2 power 2, 4 rows I will have. So, what are all the possible truth values we can do? This you all might have studied in digital electronics, that is TT, TF, FT and TFF. Right. So, next I have negate P. Negate P is just the opposite of this. So, that is F, T, T. And next we will have to find out what is negate P or Q. Negate P or Q, how do we assign the truth value for this? That is, if both negate P and Q has a truth value as F, the net resultant will be F. Where it is? Here I have both, this is F, so it will be F. Elsewhere it will be only T, so it is T. Elsewhere it is T. If I do not have these two to be as F now, everywhere it will be only T. So, now you just look into this final expression, right. So, this final expression has the truth value as T and F, right, both is there, which means that this is an example of contingency. Understood now? Hope you might be having a better knowledge if we do the problems or if we do the examples. Next is construct the truth table for the given statement P conditional Q, biconditional, negate P or Q. So here also, once if a statement is given, first thing is we will have to identify how many number of variables are used in that statement. So how many number of variables? Again only 2 variables. So it is PQ. So the truth values will be either TT, TF, FT, FF, right. So now what are the terms we have, you will have to find, that is P conditional Q. P conditional Q, how do we have the truth value for this statement? If P is T, Q is F, the resultant will be F. P is T, Q is F, the resultant will be F, elsewhere it will be only T, right. And next I have negate P. So negate P, here I should have the truth value for that. This is F, F, T, T. Next is negate P or Q. Negate P or Q, na. So the truth value of this, it will be when both negate P and Q has a truth value as F, the net resultant will be F. I'll have to find out. So here I have both FF, so it will be F, and in none of the cases I do have that thing, so it will be T everywhere, right. So next is we will have to find out what is P conditional Q, biconditional negate P or Q. So now this is you will have to just consider this term as P biconditional Q. So this term I have here and this term I have got here. So these two should have the identical truth value, only then I will have the truth value to be as T. So the identical truth value, where do I have? So I will have to see to that. I don't have the identity. See here, this is one statement, this is the other statement I have. These two should have the identical truth value. I have T, I have T. So therefore it is identical. So therefore the net resultant is T. Here also I have FF. So it is identical. Then I have the truth value to be as T. Here I have T and T. Again it is identical. Again they are identical. So therefore what is this called? So this expression, this entire expression, the truth value everywhere, if you just see, it has the truth value to be as T. So therefore, which means that it is a tautology, right. And next example we will see here. Construct the truth table for this statement. Again, in the given statement, again I will have to see how many number of variables are there. So there are only 2 variables, so it is PQ, right. So what are all the truth values we can assign? 4 rows it will be there, TT, TF, FT and FF. Next I should find out what is my P and Q. So if both P and Q has a truth value as T, then the net resultant will be T. If not, I will have only to be as F everywhere. Fine, yes. And then we will have to find out what is P or Q. P or Q is only if both P and Q has the truth value as F, it will be F. So both F, in this case it will be F, elsewhere it will only be T. And next is P and Q and negate of P or Q. So negate of P or Q, I can have one more column here. Negate of P or Q I can have here. So that is negation of this. I will have F, F, F and then I will have T here. Now look into the last entire expression here. I have this statement P and Q. Here I have got negate P or Q. I will have to find out the conjunction. So the conjunction truth value, what it will have, that is only if both these two has the truth value as T, it will be T. If not, I will have the truth value to be as F only. So I will have to find out where these two has the truth value as T. See, I have TF, definite it will be only F. FF, definite it is F. F and F, definite F. F and F, F and T, I have it to be as F only. So I only if both these truth values have the thing to be as T, then only I will get the truth value here as T. If not, I will have only false. So if you just look into this last final expression, everywhere we have only F. So this is a contradiction statement. Contradiction statement. So hope you would have understood what is all about tautology, what is all about contradiction and contingency. Yes? Okay, fine. So now we will see laws of implication and equivalences. What is all about this law of implication and equivalence? So in school we might have studied set theory. Under the set theory, what are all the properties or laws you might have come across? Fine, very good. De Morgan's law, associative, then distributive, commutative, absorption, then many things you might have studied. So keeping all that in your mind, the same thing, it will be extended for few of the connectives. So that we will be seeing under laws of implication and equivalences. So we do have many laws, but then we'll just go through only very basic laws of implication and equivalence. We have only 7. So one must be very thorough with those 7 laws of implication and equivalences. So hereafter, wherever we come across, we'll be making use of only these laws. So one should be very thorough with these basic laws of implication and equivalence. Let me give you that. So here, so we have a serial number, whatever statement you will have, and then the name of the law. Name of the law. This is very important. So first thing, if we have the statement as P and P conditional Q, right? P and P conditional Q will give us Q, right? P and Q. P and P conditional Q will give us Q. So you just think of these two will go off and we'll be left out with only Q. That is called as detachment law, right? So this is called as what? Detachment law. The second one is we'll have negate Q, P conditional Q. Negate Q, P conditional. So this and this will go off and we'll have here negate P. So that law is called as modus tollens. Modus tollens. And next is whenever we have P and Q, this will imply either P will have or P will have Q. So this is called as conjunctive simplification. Conjunctive simplification. Then suppose in case if we have the statement as P conditional Q, comma Q conditional R. So this will imply, see here the first statement it ends with Q and the second statement it starts with same Q. So if that is so now, these two will go off and you can just think in that way and you will get it to be as P conditional R. That is chain rule. That is chain rule. And next is okay, fine. So if we have P or Q, right? If we have P or Q, this is equivalent in writing as negate P conditional Q. Negate P conditional Q. So this is called as conditional equivalence. Conditional equivalence. All these are very important thing. Conditional equivalence. And next is whenever we have P conditional Q, this is equivalent in writing negate Q conditional negate P. That is called contrapositive. Contrapositive. And next is, so if we have P biconditional Q, if we have P biconditional Q, this can be written as, or it is equivalent to P conditional Q and Q conditional P. This is both forward and backward. It is called as biconditional equivalence. Biconditional equivalence. Then finally one more law which is very similar that we have studied De Morgan's law in school days, right, under set theory. That is negate of P and Q. It is equivalent to negate P or negate Q, or else if we have negate of P or Q, this is equivalent to negate P and negate Q. So this is called as De Morgan's law, right? So all these laws are very important. So these 8 laws, one must be very thorough. Like if you just see the first 4 one. So first 4 you have only implication symbol, which means that it is only if and then. If you have this left hand side statement, then this is true, right? If this is so, then this is true. The either way you cannot say. But whereas in case of the last 4 things, they are equivalent, which means that it is if and only if. If I have this, then I can say this is true, or if I have this part, I can say this is true. So that should be a distinction between these two. Laws of implication and equivalence. Implication says that only it is forward. So the first four terms, first four statements, if I have this part, then I can write it to be as this. Then whereas in case of my last four statements, either way I can write it. So one must be very thorough with this law of implication and equivalence. Okay, fine. So after this, we'll just see here, right? Implication and equivalence. Implication means it is conditional forward, equivalence means it is biconditional, if and only if. Suppose in case if a statement is given to us and if we are supposed to find out a statement, in the sense conditional statement, if a conditional statement is given to us and if we are supposed to find out what is the inverse part of that statement, still we can do it. What is the converse? Fine, we can do it. What is the contrapositive? Again we can do it. So one must be thorough with all the basic logical laws, right? So even for that also, as soon as the statement is given and if we are asked to find out what is the inverse part, immediately if we could not find now, you will have to identify the keywords, assign the identified keywords with the variable, and then we can go by the laws and then we can get it. So because this is the very first start of the class, we can do this way, and once if we get familiarized with all these things, we can go immediately even without using all these things, right? So now let us see implication and equivalence. Suppose if a statement is given, say P conditional Q, right? If this is a statement given, if this is a statement, if this is so, then this is also so. That is what it means by P conditional Q. So now what is the inverse part of this P conditional Q? What is the inverse part of P conditional Q? So inverse part of P conditional Q is nothing else, it is negate P conditional negate Q. Inverse is negate P conditional negate Q will be the inverse. So if that is the inverse, then what is the converse? That is just the ulta. So now what will be that? It will be Q conditional P. Q conditional P we have. Fine. So if these are the two things, then what about contrapositive? Contrapositive sign as well as the direction will be changed. See here, this is negate Q conditional negate P. So this is the contrapositive. So that's the difference between inverse, converse and contrapositive statement. So once if we see one example, we will be in a better position to understand what is all about this inverse, converse and contrapositive for any given conditional statement, right? So now let us see an example. If you do your homework, then you will not be punished. So what are all the keywords? You do your homework, you will not be punished, right? So let me take P to be as you do your homework, right? You do your homework, let me take it to be as P. Now Q, so Q we will take it to be as you will not be punished, right? You will not be punished, you will not be punished will be taken as Q. Now look at the statement, if you do your homework, if then. So what is the connective, suitable connective here? It is conditional. If you do your homework P, then you will not be punished. Conditional, Q represents you will not be punished. So now I am asking you to interpret what is the inverse part of the statement. What is the inverse part of this statement? How do we write it? Inverse part we know that is negate P conditional negate Q. Inverse is what? Negate P conditional negate Q. So what is negate P? If P is this na, what is negate P? Negate P is what? You do your homework, you do not do your homework. You do not do your homework is negate P. Homework. And next, what is negate Q? Q represent you will not be punished. Negate Q will be you will be punished. You will be punished. Fine, good. So now what is the inverse of this statement? Inverse is, we all know that it is negate P conditional negate Q. So negate P is this, negate Q is this, which means that what is the inverse part of the statement? If you do not do your homework, right? That is for this statement, if you do not do your homework, then negate Q is what? You will be punished. Then you will be punished. So that is the inverse part of the statement. Now coming on to what is the converse part of the statement. Converse is what? If we have P conditional Q, converse is just the ulta, that is Q conditional P. So Q conditional P, Q is what? You will not be punished. Then P is what? You do your homework. So how do we write it? That is, if you are not punished, if Q is you are not punished, if you are not punished, then you would have done your homework. You would have done your homework. Done your homework. That is the converse part. Then what's the contrapositive? Contrapositive is negate Q conditional negate P. Negate Q is what? You will be punished. So if you are punished, then negate P. You would not have done your homework. You would not done your homework. So that is the contrapositive. Understood now? So this is how one has to undergo what is inverse, converse and contrapositive of any given statement. Again here I have given you one more problem, that is if the steel rod is stretched, then it has been heated. The statement what it says, you are supposed to find what is the inverse, converse and contrapositive of the statement. If the steel rod is stretched, then it has been heated. So now let us see. So first thing, we will have to identify the keywords. The keywords are steel rod is heated. Let P be the statement, steel rod is heated. Sorry, steel rod is stretched. And Q be the statement, steel rod is heated. Steel rod is heated. So now what will be the inverse part, right? Inverse. So inverse we know that negate P conditional negate Q, right? So negate P conditional. So we will have to find out what is negate P here. Steel rod is stretched. So negate P is steel rod is not stretched. Negate is just the opposite, right? So next is negate Q. Negate Q is what? Steel rod is heated. Negate Q is steel rod is not heated. Is not heated. So now coming on to this point, how do we write it? Negate P conditional negate Q. Negate P is steel rod is not stretched. Fine. So if the steel rod is not stretched, then it is not heated. It is not heated. That is the inverse. And what is all about the converse statement? So converse is just the ulta, I said. It is Q conditional P. So Q conditional P means, well, Q is what? If steel rod is heated, then it is stretched. Then it is stretched. That is the converse part. And what is the contrapositive statement of this? So contrapositive is negate Q conditional negate P. So negate Q is what? Steel rod is not heated, right? So steel rod not, if steel rod is not heated, then it is not stretched. Not stretched. That's all. See, now it will be very simple. Whenever we identify the keywords and we can assign it to the variables, after that we can go by these statements. Then it will be very easy and we will not go anywhere wrong. So this is how one can find out the inverse, converse and contrapositive of any given conditional statement. Yes. Okay, now let us see. Already we know how to construct the truth table for any given statement. Either the statement may be a compound statement or it may be an atomic statement. We know how to construct the truth table. And now after seeing the laws of implication and equivalence, without constructing the truth table, still we are in a position to find out the truth value of the given statement. So that we will do here. Show that P conditional, Q conditional R is equivalent to P conditional negate Q or R, and that is equivalent to P and Q conditional R without using the truth table. So let us see. So without using the truth table, if it is asked now, definitely we should not make use of truth table. So now we should be thorough with all the basic logical laws of implication and equivalence. So now see here, we'll consider the left hand side part. So the left hand side part is what? That is P conditional, Q conditional R. So simultaneously we also have to look into the right hand side part of the problem. So now right hand side part is this. So this P conditional, I will have to retain it as it is. Only thing is that I will have to simplify. So here I have got negate Q or. So if this conditional has to come as or now, what law I have to apply, that I have to think over. So whenever we have to replace our conditional by disjunction, the only suitable law we call it as conditional equivalence. That is what it is, negate Q or R. So this is conditional equivalence. We have the law as conditional equivalence. What is that law called? Whenever we have P or Q, this is equivalent in writing, negate P conditional Q. So that way if I write now, instead of either way I can write it. So if I have this now, I will write this. If I have this, I can write this. So that way if I write now, I get this term. And now look into this I have got it. From here again I will have to get this term. So this is equivalent to. Now see here, this after this P, I don't have the connective as conditional. Instead it has got here and. So I will have to somehow remove this. If I have to remove this conditional, again I can apply this conditional equivalence. See, whenever we are supposed to remove the conditional, the only law which is suitable is conditional equivalence. So if I apply that law again, I will get this to be as negate P or negate Q or R. Again this is conditional equivalence. And now see here, right hand side, I am just clubbing off my PQ. See here, what is that law called? That is associative. So I will be applying here the associative law. So that is negate P or negate Q or R I will be having here. And again see to the conclusion part of the problem, I don't have negate anywhere. So I will be applying De Morgan's. I can take it outside. So negate of P and Q or R. Right. So here I have applied De Morgan's. And after still I am not able to get this part. So again conditional equivalence, either way I can have na. So this if I have, I can write this. So which means that this is negate P or Q, which means that I will be having this to be as P and Q conditional R. See, this I will have to consider it as one single term, right? This I will be considering it as P and this I will be considering it as Q. So if I have negate P or Q na, this is equivalent in writing. P if I have, I write it as negate P. Negate P na, I will have it to be as P. So this Q will be retained it as it is. That is what we have written. So that is the RHS part. Now I hope everybody will be understanding how to get the truth value of the given statement even without construction of truth table. Right. Again one more thing also, if you want you can just see here, that is prove that P conditional Q and R conditional Q is equivalent to this. So we will take our right hand side, simplify it and we will keep it aside. Again we will take our left hand side, we will simplify it and we will keep it aside. So then these two, it must be one and the same, only then we will say that they are equivalent to each other, right. So now let me consider my left hand side alone, right. So this is equivalent to P conditional Q and R conditional Q, right. So this is equivalent to conditional equivalence I can apply here. If I apply conditional equivalence, I will get here what? Not P or Q, and here this is and not R and sorry not R or I will get Q, not R or Q. So I have this now. So this is equivalent to, which is common, here Q is common. Can I apply the distributive? What is the distributive property we have? So distributive property is what? A and B or C is equivalent to A and B or A and C. The other thing, if I have A or B and C, then this is equivalent to A or B and A or C, right. So this way we can write it. So now I have A or B and A or C, that is this. If that is so, now this is equivalent in writing the term as A or B and C. So I will have to find out what is my A. My A is this, negate P. So negate A is what here? I'll have to see the common term. The common term here is what? It is Q. So I can write this to be as Q or negate P and negate R, right. Q or negate P and see, if I apply the distributive, then I do get this to be as Q or negate P and Q or negate. So this is again equivalent to Q or, right. I can apply the De Morgan's and I can take this outside. So if I take negate outside, I do get this to be as P R R, right. P R R I am getting here. So now this is equivalent to, right. So this is equivalent to, again if I still want to simplify this, I can simplify. So how do I simplify this? Sorry, here in this case we should have it to be as R, not as Q, it should be R. So now how do we write? I can apply the commutative. What does commutative says? Negate of P R R or Q, right. So this is commutative I have applied. Commutative I have applied here. Commutative is nothing else but if I have A or B, na, this is equivalent in writing B or A. So this is equivalent to, again conditional equivalence I can have. Conditional equivalence, see here, if whenever I have P or Q, it can be written as negate P conditional Q. That is what here. So that is P or Q, P or R conditional Q. So that is what my right hand side, right, understood. So we have started with LHS even without constructing the truth table, still we can get the result of our given statement, right. So this is how one will be using the basic logical laws of implication and equivalence in order to get the conclusion part of any given statement. Understood? Yes, thank you.